Myself, Shafia. My topic about movements. Theory. Movement is a turning effect of a body around a pivot point. The algebraic formula for movement is force x perpendicular distance from the pivot point, that is m equal to F into d. Turns unit of moment would be n to m, etc. Principles of movement. The principle of movement states that the moment of a force about a point is equal to the sum of the moments of the force component about the point. This is particularly convenient since it is often easier to determine in the moments of a force component rather than the moment of the force itself. For its example, in two dimensions. What is moment? A moment is a numerical measure used to describe certain properties of a probability distribution or a random variable. They give information about the shape, spread, and location of the distribution. Think of moments as statistical fingerprints that summarize how data is distributed. Why do we use moments? We study moments because they summarize important features of a random variable, describe central tendency or average behavior, describe spread or dispersion, how data varies, describe shape, symmetry, skewness, peakedness, provide mathematical tools to compare two different distributions. There are two types of a moments for a function of a random variable x. First one, moments about the origin, and second one, moments about the mean or central moments. Let g of x be a real function of a random variable x such that g of x equal to x power n for n equal to 0, 1, 2, 3. The expected value of g of x is called the moment about the origin of a random variable x. It is denoted as mn, where n indicates the order of the moment. Mathematically, the nth moment is defined as the mn equal to e power xn equal to integral minus infinity to infinity x power n fx of x dx for a discrete random variable. E of x power n equal to summation of xi power n p of xi. If n equal to 0, m not equal to integral minus infinity to infinity x power 0 fx of x dx equal to 1. The zeroth moment m not equal to 1 gives the area under the PDF. If n equal to 1, m1 equal to integral minus infinity to infinity x fx of x dx equal to e of x. The first moment is equal to the mean value m1 equal to x bar. If n equal to 2, m2 equal to integral minus infinity to infinity x square fx of x dx equal to e of x square. The second moment represents the mean square value of x. If x is a random signal, m1 gives the average value of the signal and root of m2 gives the RMS value of the signal. Let g of x be a real function of a random variable x such that g of x equal to x minus x bar power n for n equal to 0, 1, 2, 3, where x bar is the mean of x. The expected value of the function g of x is called the moment about the mean of the random variable x. It is denoted as mu n, where n indicates the order of the moment. These are also called the central moments of the random variable x. General formula. The nth central moment of a x is given as mu n equal to e of x minus x bar power n equal to integral minus infinity to infinity x minus x bar power n fx of x dx. For a discrete random variable, the formula becomes mu n equal to summation of xi minus x bar power n p of xi. Case 1. When n equal to 0. Mu naught equal to e of x minus x bar equal to integral minus infinity to infinity x minus x bar power 0 fx of x dx. Since anything raised to the power 0 is 1, mu naught equal to minus infinity to infinity fx of x dx. But the total area under the probability density function is always 1. So mu naught equal to 1. This means the zeroth central moment is always 1. Case 2. When n equal to 1. Mu1 equal to e of x minus x bar equal to integral minus infinity to infinity x minus x bar fx of x dx. Expanding this, mu1 equal to integral minus infinity to infinity x fx of x dx minus x bar integral minus infinity to infinity fx of x dx. The first term integral minus infinity to infinity x fx of x dx is the definition of the mean x bar. The second term x bar integral minus infinity to infinity fx of x dx is x bar into 1 equal to x bar. So mu1 equal to x bar minus x bar equal to 0. Thus, the first central movement is always equal to 0. Thank you. Give me this opportunity to me.